Okay, let's get these dogs out of the way and see what we're trying to do. It looks like something with triangles. Ah, right triangles. Oh, we're going to solve right triangles. All right, let's get these dogs and puppies out of the way. Hey, we've been working with triangles quite a bit this year, and we have learned there are 6 pieces. Again, when we're doing the proofs, we often saw that if we had 3 of the pieces, we could actually prove that it was congruent to another triangle. And so here we are going to go and solve triangles, say, hey, you know what, if we get 3 pieces, we usually can find the other 3. Right? Now, if one of the 3 pieces is a right angle, wow, this gets greatly simplified. If we don't have a right angle, come back for the next 2 lessons. This lesson, though, every triangle will be a right triangle. It'll have a right angle. Okay, I love this type of question, right? It's like, okay, here's the information. These are the 3 pieces you know. Please find the other 3 pieces. Very first thing that I'm going to probably do is either I'm going to print out the worksheet, or maybe I'll copy the questions on paper by hand. But other than that, the first thing I'm going to do, I got to get in Bob Ross mode here, man. I got to paint a picture. We're not going for artistic perfection. It does, though, need to look like a triangle, and you need to label the right angle. All right? So try and draw or sketch something that resembles a right triangle. Don't be too concerned about the shape, other than it's got to be a right triangle. I will always use C for the right angle. The A and B are mix and match, though. Right? Either acute angle could be A, either acute angle could be B. Once I have my ABC labeled, I say, aha, let's put in the pieces we know. I know that angle A is 36 degrees. I know that side B is 8.2. Of course, side B is opposite angle B. Because it is a right triangle, if I know 2 angles, I actually know all 3 angles. All right? They have to add up to 180. That will help me find my 3rd angle. Now how am I going to find a side? Well, pick an angle. I'm going to pick 36 degrees. Now I know which side should be labeled opposite, what side should be labeled adjacent, and of course the hypotenuse, that's not going to change. So, because of SOHCAHTOA, I know that the tangent of any angle theta has to be opposite over adjacent. Why did I pick tangent? Well, I'm trying to find the opposite, and I know the adjacent. So tangent of 36 degrees. Okay, now the opposite leg is A, because it's across from angle A. And then the adjacent leg is 8.2. So 8.2 times the tangent of 36 degrees has to be side A. I'm going to need a calculator. Notice I got to make sure that it's set for degrees. Directions don't tell me where to round off, so I'm just going to do the nearest tenth. So I had to choose between 5.9 and 6.0. It looks like this answer is a little bit closer to 6.0. I can add that to my diagram. I can add it to the answer display. Finally, I've got just a missing side, but because this is a right triangle, I can use the Pythagorean theorem. There's my Pythagorean theorem, a squared plus b squared is c squared. I could have plugged in the 6, but because I'm using the calculator, I already had that value plugged in there, right? But if you just use a 6 instead of that lengthy decimal, you're still going to get an answer very, very, very close to 10.1. And again, I can add that to my diagram, and I can add that to my answer display. And there we have solved the triangle. I was given 3 pieces. I found the other 3 pieces. And again, if I'm given 3 pieces, usually I can find the other 3. So draw my right triangle, label it ABC. Once I have it labeled ABC, I can now plug in the numbers in the correct locations. Well, I guess I can't start by looking for an angle because I have to know 2 angles to make them add up to 180. I only have 1 of them. So, well, let's try to figure out angle A. But I can't make them add up, so what am I going to do? Well, I know what side is opposite. I know what side is adjacent. I know what side is hypotenuse. Aha! Opposite over hypotenuse. Sine. Sine of any angle theta is opposite over hypotenuse. Okay, now in particular here, I though want to learn about angle A. So sine of angle A, opposite over hypotenuse, becomes 3 over 7. So angle A will actually be inverse sine of 3/7. Calculator, again, make sure it's set for degrees. Looks like the answer is pretty close to 25 degrees. If I go to the nearest tenth, I'll say 25.4. I can put that in my answer display also. Hey, now I do know 2 of the angles, which means I really know all 3 angles because they've got to add up to 180. I can add that to my diagram. I can add that to my answer display. Finally, if I know 2 sides of a right triangle, the easiest way of finding the 3rd side is the Pythagorean theorem. Notice I'm going to come up with a quandary here. Normally with square root of 40, I say, hey, come on, just simplify it and leave it as an exact value. Except if you look at angle A and angle B, we don't have exact values. We've got decimal approximations. So this is kind of a wild card here. Some of you are going to say, hey, I'm going to take that square root of 40 and I'll simplify it and I'll make it 2 root 10, which is an exact answer. Some of you will say, nah, since we already used decimal approximations on the angles, you might as well just use a decimal approximation here. And so if you want to just put 6.3 instead of 2 root 10, right, because it's one of these weird things where in, oh, do I dare use the phrase? Yeah, in circular trigonometry, we tend to want to try to come up with exact values. But with right triangle trigonometry, mathematicians often will just go for decimals. And we're doing right triangle trigonometry here, not circular trigonometry. So decimals are cool enough. So today you will always have a right angle. Because it's a triangle, you can always use the fact that the 3 corners must add up to be 180 degrees. Because it's a right triangle, of course, you may always use the Pythagorean theorem, also known as a squared plus b squared equals c squared. And because it is a right triangle, you can almost use your friend SOHCAHTOA, right? The ratios for sine, cosine, and tangent. Fair warning though, sometimes instead of using sine, cosine, or tangent, you may have to use the inverse sine, inverse cosine, or inverse tangent. We started off chasing a bunch of dogs off the screen so we can see what the learning target was. So now after those dogs have run around a party, they're probably tired out, and oh, look at this puppy. Oh, this puppy is doing what a lot of puppies love to spend a lot of time doing. They just nap. When they're really young dogs, they spend a huge chunk of their time just sleeping the day away. Wish I could just sleep away the day sometimes. Okay, well, there is the lesson.